Very good morning, students. For this lecturing video session, I am going to solve a problem from projections of solids. Let me just read out the question first to make you understand what has been given here and what needs to be drawn. That means the projections, right? A pentagonal pyramid of base side 30 mm and 60 mm long, which is lying with one of its triangular faces on the HP and axis parallel to VP, draw its projections, right. Let me just take down the given data. So what has been given here? The object here is a pentagonal pyramid. So object is a pentagonal pyramid. Pentagonal pyramid of side 30 mm, okay, and 60 mm long. So what is 60 mm long? The axis is 60 mm long, or axis is 60 mm height, or axis is 60 mm altitude, or axis 60 mm length, right. So the axis height is 60 mm. AH is nothing but axis height, which is lying one of its triangular faces on the HP. So that means where it is resting on HP. So resting is on HP. How it is resting? With one of its triangular faces. With one of its triangular faces on the HP. With one of the triangular face. That's triangular face, right. Is there any axis inclination given? No, it's a special condition problem, right. Let me just draw the XY line. This is a horizontal line, that is nothing but the reference line. Above XY is VP and below is HP. So as far as projections of solid is concerned, it is being divided into two stages. Stage 1 is for the symbol position or symbol resting. Symbol position or symbol resting. And the stage 2 belongs to axis inclination or any special conditions right. So where to start the diagram? So when the object is shown the true shape, where you could see the true shape, there you will have to start the diagram. So here the object is a pentagonal pyramid. So how you differentiate the pyramid? By the shape of the base, right. According to the size of the base, you will just name it, it's a pentagonal. If the base is hexagon, then hexagonal pyramid. If the base is square, then it would be a square pyramid, isn't it? Here it's a pentagonal pyramid. So pentagon has 5 equal sides, isn't it? Yeah. This is apex. This is a extreme top. There is a top is apex or vertex. How the object is being placed? One of its triangular faces. One of its triangular faces is on HP. So here, as far as this drawing is concerned, where is the triangular face? These are triangular faces. How it is resting? With one of its triangular faces in this manner. It's on the HP. And the axis is parallel to VP. So this is how it's lying, right. So when it is resting with one of its triangular faces, whether you could see the true shape of this object, that is the pentagon? No. So in that scenario, so the change of position method, that means the axis should be perpendicular to any one of the plane in order to draw the true shape of the object, isn't it? So this is the final position where the object is lying with one of its triangular faces on HP. So in order to draw the true shape, I am going to make the axis perpendicular to HP. Now the axis is making 90 degree with HP, therefore I could see the true shape on HP. Looking from the top, I could see the pentagonal shape, that is a true shape, right? So this is what I am going to draw. So look at here, whether the corner or edge should come on the right hand side. How it is resting with one of its triangular faces. This is the triangular face, right? If it is lying in this manner, look at here, what is there? This is the side or edge which should be kept on the right hand side. If you keep the corner in this manner, it won't rest on the triangular faces, because it will rest on the longer or the slant edge, isn't it? So you remember that if it is resting with one of its triangular faces, then the side or edge should be kept on the right hand side, right? So I have to draw the true shape on HP. What is the side? The base side is 30 mm. So draw a line of 30 mm. So as far as pentagon is concerned, what is the internal angle? Which is 108 degree, 108 degree, isn't it? So keep your protractor in this manner. Similarly here, in this manner, right? Now take 108, this could be 90. So 108 something like this, so extend this line. Similarly here also you will have to take 108. So from here, if you take, it's a 90 degree. Then 108 would be something like this, extend this line. Now take 30 mm in your compass. Keeping at the extreme point, cut an arc. Similarly, keeping at the extreme below, cut an arc. Now without changing the radius, keep it in the intersection point and cut an arc. Similarly, keeping at the intersection point, cut an arc. Now connect all the intersection points or the line which has been, the arc which has been cut on the extension line. So now draw it. So remove the wipe off the lines which are not required. Lines are not required. So this is the pentagonal shape, that is a true shape of the object. True shape of the object is a pentagon. So this is what. Here the object is a pentagonal pyramid. So when I look at from the top, I could see the apex or the vertex, right, in the top view. So for which I need to draw the axis, that means I need to find the center, that is the axis. So how that can be drawn? So this is the corner, opposite side center, mark it and draw a thin line. Draw a thin line, right? Similarly, here it is a corner, opposite side center. Now connect the center and the corner. So now there is an intersection point. So this is nothing but the apex or vertex, which can be named as O. Now connect all the corners with the apex. So in this manner, So by doing so, look at here in the right hand side, what is the condition? It says triangular faces. You could see the triangular faces, that one of the triangular faces is on the right hand side. Remember? So now I am going to name each and every corners here. So this could be A and this could be named as B, C, D and E. Correct? Now I need to draw the front view, for which I need to project from each and every corners of the top view vertically. Let me just project vertically upwards. So B and E will lie on the same line. So now this is the axis, that also I am just extended. So this is how. So what is the axis side here? Which is 60 mm. How the axis needs to be represented? long line dot long line dot long line. This is how the axis should be represented, right? What is the height of the axis, which is 60 mm? From the reference line, take 60 mm and cut an arc. And this could be O dash, that is the apex or vertex. Now boundary should be closed. So when you just look at from the front, you could see there is a slant edge, right? The slant edge would be visible when you just look at from the front. So close that boundary. Close that boundary. Now the base also. Right. Now look at from here. What are the slant edges are visible. AO would be visible. BO would be visible. CO would be visible. So therefore, this could be A dash and B is here. Right. So draw a slant line which could be B dash and C is visible. Therefore, this could be C dash. Then what about D and E? D and E are invisible because D is right behind C, E is right behind B. Therefore, invisible needs to be captured within the bracket. So, D is invisible. So, I have captured within the bracket. E is invisible. So, which I need to capture within the bracket. So, here the object was kept in this manner, keeping the side on the right hand side. When you just look at from the top, I could see the true shape of the pentagonal pyramid. There is a pentagon is visible, which I have drawn here. When you just look at from the front, I could see a triangular shape, isn't it? When you just look at from here, the front. So these are the points which would be visible. A, B, C are visible. D and E are invisible, which I captured in the front view. Then let me just move to the stage 2. It refers, this stage 2 is for axis inclination or special condition. So as such, this question doesn't have any axis inclination. In this question, it says that triangular face is on the HP. That means initial position, that is a simple resting was in this manner, resting on edge. Now the second stage, the rectangle, so the triangular face is on the HP. It's lying on the HP. This is what I am going to do. Right. So this particular C and D should lie on the XY line. C and D should lie on the XY line. So let me just choose a point here and let me just give the naming for this C1 dash and D1 dash. Right. Now measure the distance of C to O dash. Measure the distance between C dash and O dash in your compass, keeping at C, cut an arc. This could be O1 dash. Right. This slant edge, that is CO, has been kept on the XY line. This is how. Right. This CO is on the XY line now. Now measure the distance between A and C in your compass. Keeping at C, cut an arc. Cut an arc. Now measure the distance between A and O, A dash and O dash in your compass. Keeping at O, cut an arc. Right. So now this becomes A1 dash, isn't it? So now connect the point A and C. This is the base. And A to O, and this is the slant edge. Now measure the distance between C and B in your compass. Keeping at C, cut an arc. And this point becomes B1 dash and E1 dash. Now connect BO. Connect BO. Look at here. This particular object has been transformed. That means keeping CO on the XY line. On the XY line. Clear? Right. Now, final top view. How that can be drawn? So by simply extending the projectors, so from the front view as well as from the top view, this needs to be extended, right? So now I'll have to just draw the projectors. So before that there is a axis, right? So this axis also you just transform here. So measure it from C to axis and connect it. So now draw the axis. Now project all the visible and invisible things, vertically down, and from the top view we'll have to draw the horizontal projectors. Horizontal project. Now I got a box over here. So within the box only I am going to get the final top view. So in order to draw the final top view, what I need to do? So what I have to do is to see the intersection or meeting points. So A is here, AAR, that means the horizontal projectors and vertical projectors would be meeting at one point, right? That's what I am going to do now. A is here and A. So A and A are meeting here, and this could be A1. Now B and B are meeting here, this could be B1. C and C are meeting here, this could be C1. And D and D are meeting here, this could be D1. E and E are meeting here, this could be E1. What about the apex? O and O are meeting here, this could be O1. So first what you have to do? You will have to do that means the boundary should be closed. So boundary should be closed, isn't it? So this is the object is being placed. So the boundary should be closed by drawing the lines, that's the sides, EB, DC, CB. Now connecting the slant edges, that is BO and EO. Clear? So next what I have to do? I have to follow the checklist. So in order to draw the visible or invisible things. So now the base is connected A to B, B to C, C to D, D to E and E to A. That means A to B, B to C, C to D, D to A and E to A in that manner. Next, slant edges. What are they? AO, BO, CO, DO and EO. Right. When the object is inclined, in that means now it is resting on one of its rectangular faces. When I look at from the top, I could see all the faces. That means the sides, all the edges, isn't it? All the edges would be visible. So what I have to do? I have to connect all the sides, right? Right. This is how the object is lying. When I look at from the top, I could see all the corners. That is A, B, C, D, E. Everything is visible for me because I am just looking at the object orthogonally. That is 90 degree to it. So by doing so, I could see all the edges. Next what? Next the slant edges. AO. Look at AO. AO is on the top. AO is on the top. So AO is visible. So this is how the object is, right? The A is here. The object A is here. AO is visible. Then BO. This is AO. Sorry. BO, AO and EO are visible, isn't it? This is how the object is. This is B. This is A and this is E. What about C and D, which are right behind the slant edges? That is BO, AO and EO. Therefore, DO and CO are invisible. Right. So now AO is visible. I am just drawing a visible line or the object line or the outline. Right. EO and BO is already visible by doing by closing the boundary, isn't it? What about DO and CO, which are invisible? So by doing this, that means dotted line, drawing dotted line, you have to show it. That means invisible. Dotted or dash line. Right. So I have thought to hint for you, isn't it? What exactly it is? How it is resting with the side C and D. So the one which has, connecting that is slant edges. CO is connecting, DO is connecting. Therefore, C and DO are invisible, isn't it? Next, notes. By doing this, I have completed all the 4 drawings. That is 2 front views and 2 top views. These are the projections of this particular object when it is resting with one of the the triangular faces, isn't it? Now allow to mark their dimensions here. So first, the side of the pentagon is 30 mm. So draw a perpendicular line to the side, extend this is the extension line. Now draw a line which is parallel to this side, that is the dimensioning line. So now fill the arrow. The arrow head should be 3:1 or 1:3, right? The width is 1 and the length is 3. So over this you will have to write it, right? 30 mm. So 30 mm. 30 mm. Now the axis side needs to be mentioned. That draw a parallel line to the reference line. Now parallel to the axis, and over the dimension line, we will have to mention the dimension, that is 60 mm. 60 mm. Is there any axis inclination? No. So we need not to specify it. Right. So with this, I have completed all the 4 drawings. Next, what I have to do? Note. So in the right bottom of the diagram, just open up a guideline of 5 mm height. 5 mm height, the guideline, and mention all dimensions are in mm. All dimensions are in mm. Mm should be lowercase, that is the small letter you will have to use. Next, scale. Scale is true scale because I haven't changed any of the dimension. That means 30, same thing I used for the side, 60, same thing I used to draw it. So the scale should be 1:1, which is nothing but the true scale. Hope you have all understood this. Thank you.